In this tutorial, we're going to take a look at a number of examples of using the exponent laws to simplify expressions. I'm going to focus more on the simplifying rather than the evaluating, but I'll do a bit of that too. So first of all, when you're multiplying powers with the same base, and this is what this looks like. So here's two different powers, and the bases are both a in this case, so they're the same thing. So we have a raised to the exponent m multiplied by a to the exponent n. Then the simplified version is a to the exponent m plus n. We add the two exponents. So for example, in the first one here, these both powers have the same base of 6, so the answer is going to have a 6 as a base, and we add the two exponents, 5 plus 4 as to 9, so that will simplify to 6 to the 9th. Now if you want to evaluate that, you could just do 6 raised to the exponent 9, so that's what it would equal. Second one here, the base is -2, so the answer is going to be -2 to the exponent of, and we add the 3 and the 5 to get 8. So once again, if you want to evaluate that, raise -2 to the exponent 8, and that would equal 256. Now we can also use this to multiply monomials together, for example. So this is one polynomial expression, same with this one here. So we multiply the 3 and the 5, that's just 15. And then we have some powers to multiply. So x to the 4th times x to the 3rd, common base is x. So we add the exponents 4 and 3 add to 7. Now when we're multiplying the y squared and the y, over here we don't see an exponent, but it's automatically a 1. So we add 1 and 2, and then that's 3, so that would be y cubed. Remember what the exponent means. It means how many y's are multiplied. So there's 1 here, there's 2 here, so altogether there's 3. Now I want to compare these two. The only difference is the brackets. The brackets are around the -4 here. Here there are no brackets. So -4 in brackets squared means -4 times -4, which would be positive 16. But this actually means -4 squared, -4 times 4. So if you wanted to put brackets, the only place you could put brackets around this to keep it the same would be like this, and so they would be here. See, there's the 4 squared, and so that's 16, and this makes it negative, so the answer is -16. You can check both of those in your calculator too. See, the first one, that's the first one, and if I do -4 squared, I do get the opposite answer. So there's a difference of 32 between the two of those. They are not the same thing. Dividing powers of the same base. We were multiplying here, here we're dividing, so a to the exponent m divided by a to the exponent n is a to the exponent m minus n. We subtract m minus n in the exponent. So for number 2 here, for example, 4 to the 9th divided by 4 to the 3rd equals 4 to the, and we go 9 minus 3 is 6. So that's 4 to the exponent 6. And once again, if you want to evaluate that, you could. It's 4,096. Now in B here, the exponent on the B here is a 1, just like over here when we had y to the exponent 1. So 7 minus 1 will be 6 for the exponent. A little bit about this one. It's common for a lot of students to think this should still be b to the 7th. It's kind of like, oh, I'm dividing by 1, so it's the same thing. But you see, this b in the denominator divides out with one of the 7 b's up here, leaving 6 of them. So that's why there's now 6. For C, 2 powers of the same base, so it's -3 to the exponent of, we go 12 minus 5 would be 7. And again, we could evaluate that if we wanted to. In D here, 28 divided by -4 is -7. Now we have d cubed divided by d cubed. I'm going to get into the 0 exponent in a moment. See, 3 minus 3 is 0 in the exponent, so it's d to the 0. For now, just think about I'm dividing something by the same thing. D cubed divided by d cubed, they're the same thing, so that should equal 1. So that's why there's no d's here. I could write d to the exponent 0, but I'll get into that on the next page. So the d's are gone. E to the 8th divided by e to the 5th. We subtract the exponents. 8 minus 5 is 3. So it's negative 7e cubed is the simplified answer for this. Powers of powers. So the law looks like this. We have a power here raised to the exponent n. So it's like a power of a power. And we multiply the exponent. So this would be a to the exponent mn, m times n. So for example, in a here, if we have 8 squared raised to the exponent 5, or the 5th power, then 2 times 5 is 10. Now we could evaluate that. That's starting to get quite a bit bigger. 8 to the exponent 10. That's getting to be a pretty big number. In b here, we square. That square means it's applied to both the 4 and the x cubed. So the 4 gets squared and the x cubed gets squared. So 4 squared is 16. That's 4 times 4. And x cubed squared, we multiply exponents, so that would be a 6 here on the x. Similar in c, the negative 5, the a to the 4th, and the b to the 6th, they all get raised to the exponent 3. So negative 5 cubed is negative 5 times negative 5 times negative 5. That's negative 125. And for the powers here, we multiply 4 times 3 to give you 12 for the exponent in the a, and 6 times 3 is 18 for the exponent on the b. So the zero exponent. If you have a zero exponent, anything to the exponent 0 is always equal to 1, with the exception that you can't raise 0 to the exponent 0. For example here, 7 raised to the exponent 0 is 1. Now this is just an arbitrary large number. Doesn't matter what it is, raised to the exponent 0 is 1. Really small number, negative, doesn't matter, still 1. I mentioned about you can do, for example, the 12,000. I'm going to do that b one here, the exponent 0. See, I get 1. But you can't do this. You're actually dividing by 0. That's what you're doing when you have 0 raised to the exponent 0. So you can't divide by 0. So that's why your calculator will give you an error. Now this D1 is a little bit different. You see, there's no brackets here, so it's only the 5 that's being raised to the exponent 0. So that part would be 1, and then this would make it negative. So that's negative 1. And I didn't do this as a separate example, but here's the negative 5 to the exponent 0. So there's the negative 1. If I put that negative 5 in the brackets, then I get positive 1 again. So that's the difference the brackets makes. One more here in E. 9 to the exponent 4 divided by the same thing. So remember the division rule from the previous page. We subtract the exponents. 4 minus 4 is 0, so that would equal 1. Powers of quotients. So if we have a fraction, a rational number raised to the exponent n, then both the numerator is raised to the n, and so is the denominator raised to the exponent n. So a couple of examples of this. If we had 2/7 raised to the exponent 4, so it would be 2 to the 4th over 7 to the 4th. And I didn't evaluate this in the presentation, but if you want to see, that's what would be in the numerator, and that's what it would be in the denominator. So it would be 16 over 2,401 if you want to evaluate it. B here, 3 squared over 11 to the 4th raised to the exponent 5. So see, that's the power of a power rule. So the 2 times 5 here and the 4 times 5 in this exponent. So this would be 3 to the 10th over 11 to the 20th. I'm not going to bother to evaluate that one because it's just too huge. Okay, so for example, if we do 11 to the exponent 20, see, if you know anything about scientific notation, see, that's 6 point, and then there would be 20 decimal places. Okay, so it's a huge, huge number. C here, a to the 5th over b squared to the 7th. So again, we multiply the 7 by both exponents. So and so 5 times 7 is 35 in this exponent. 2 times 7 is 14 here. So that would be how you'd simplify this. And the last kind of exponent rule or law, if we have a negative exponent, a to the negative n is equal to 1 over a to the n. So for example, if I have 5 raised to the negative 2, so that's 1 over 5 squared. Now, if you wanted to, of course, that's 25. So you could write this as 1 over 25 if you wanted to evaluate it. In B here, same idea. It'd be 1 over negative 3 raised to the positive 5. And again, if you wanted to evaluate that, it would be negative 3 to the 5th. Okay, so it would be negative 1 over 243. That if you wanted to evaluate that. Now, really, what the negative exponent rule or law says is that a negative exponent results in a reciprocal. See, it's instead of 5, it's 1 over 5. Instead of negative 3, it's 1 over negative 3, and raised to some exponent. So if you have a fraction here, raised to the negative 3. So that's the same as taking the reciprocal of the 2/7, which is 7 over 2, raised to the now positive exponent 3. And of course, we apply the power of quotient rule here. So this would be 7 cubed over 2 cubed. So, and of course, you could cube that and get a fractional answer if you want to evaluate it. Similar idea here. Notice the exponent's negative. So I take the reciprocal of this. So the 3y to the 5th is on top now, and the 4x squared in the denominator, and the exponent becomes positive 2. And so I just square all this. So 3 squared is 9. 4 squared is 16 at the beginning of the top and bottom. Y to the 5th squared, so I multiply 5 and 2 for 10 here. 4x squared, so the x squared, 2 times 2 is 4. That's the new exponent, 4. And one last page. I made up 5 examples here of varying different exponent rules. So this one has some multiplying and dividing powers of the same base. So for example, we're multiplying, so 4 plus 3 is 7. So 5 to the exponent 7 divided by 5 to the exponent 6. Dividing, we subtract the exponent. So 7 minus 6 would be 1. So 5 to the exponent 1, is just 5. So that's the simplest way to write that as a final answer. In B here, we have several different parts. So everything here gets raised to the exponent 5 and everything here to the exponent 3. So I'll start with, we have negative 2 raised to the exponent 5 and also the x cubed. And then in the denominator it would be 4 cubed and then x to the exponent 6 and then cubed. So I'll evaluate this. Negative 2 to the 5th. I know it's negative 32, but just want to show you. So that's negative 32, and in the denominator 4 raised to the 3 is 64. So we have negative 32 here. Now, power of a power rule, so we multiply the exponents. That'll be 15. 3 times 5 is 15 here. And I just showed you that's 64. 6 times 3 is 18. Now, I can reduce this. 32 divides into both of these. So if I divide negative 32 by 32, I get negative 1. And if I divide 64 by 32, I get 2. So I just have negative 1 over 2 here. We're dividing powers of the same base. So 15 minus 18 is negative 3. Has a negative exponent, and you generally are asked to write things with positive exponents only. So we would rewrite this as negative 1 over, and see this x to the negative 3 becomes x cubed in the denominator. So that's the simplest version of this. C here, we have these two powers of the same base. We're dividing, so we subtract the exponents. So 4 minus 9 is negative 5. And remember, the negative exponent means the reciprocal. So instead of 6 over y, it's y over 6 raised to the positive exponent 5 now. And of course, that would be y to the 5th over 6 to the 5th. And again, we could evaluate, if you want to evaluate the denominator, that would be 7,776 underneath the y to the 5th. Second last one here, so we're multiplying. Negative 4 times 6 would be negative 24. A cubed times a squared, powers with the same base, so we add the exponents. 3 and 2 is 5. And similar idea here. Remember, there's a 1 here, so 1 and 5 would add to 6, so it's b to the 6 on the end. For this last one here, we have power of a power, because we see these exponents here on this and this. So 7, so we multiply the negative 3 and the negative 6, so 18 is the exponent of 7. 4 times negative 6 would be negative 24 for the exponent of the x. And then for this power of 7, negative 5 times 4 is negative 20 in that exponent. 6 times 4 is positive 24. So these two powers have the same base, so we're multiplying powers the same base, so we add the exponents. 18 and negative 20 is negative 2. And on the x's, now negative 24 and 24 would add to 0, so that's just x to the 0, which is, of course, 1. So this is really just 7 to the negative 2, which would be 1 over 7 squared. And, of course, if you wanted to, you could evaluate the 7 squared and write that as 1 over 49 if you wanted to evaluate it. And that would be the final answer. And that's the end of the tutorial.